Welcome to class number 89. As I told last time, two practice questions. Once I will take UVL this way with a 2-point load. I first thought of taking 3-point load. Too sufficient, understand the concept. Then UVL this way with the 2-point loads. Last part of this one, that is UVL with the point loads. If you remember, in the previous classes, for this type of question, your SFD crossed the baseline somewhere in between the loads. So, the point X to be located, that is the point where bending moment is maximum. Both the problems, here next question also same thing happened. There were 3 loads are there. So, that in those 2 questions, effort is more, because why? You have to locate the point where shear force 0 here. But here, the question is set so that the SFD will cross the baseline suddenly at a known point. That is, I know it will cross here, here it will cross here. How means I know how to set the question. See, I have not solved anything. I just wrote only the question. I made everything ready here. Now, in front of you, I will calculate and get the answer. So, that means you can make out how easily question can be solved. But you should write systematically and solve to get proper grip. Remember, compared to the previous 2 classes, these questions are very, very easy. Therefore, I will only explain briefly and enter the values. You should calculate correctly everything and get the answer. Okay, start first question. Minus VB into 10, I will calculate, okay. Plus 20, calculator is not on, okay. Plus 20 into 3, plus 60 into, this is 10 means 6 meter, plus half into 10 into 12 into, from here to here is 2 by 3 of 10, divide by 10, I got the reaction, 82 kilonewton. This is next entry after everything is over. 82 kilonewton. Sigma V0, I don't have to explain. Minus 60 minus 6 into 10. 58 kilonewton is VA. So reactions came for first question. Now, once you get the reactions, what you have to do? To draw SFD BMD, intermediate points, I will mark C and D. You need intensity here, intensity here. From similar triangles, get it. It will come 12 by 1.2, 1.2 into 3. This will come 3.6 kilonewton per meter, calculated value, and that will come 7.2. Why unnecessary calculate? Double of that one. But you calculate Kn per meter. Now ready for SFD BMD. I will draw later. Start second question. Take moment about A. Same as last time, only change is that half into 12 into 18 into moment about A means there it was 2/3. Here it is 1/3. That is the only change. Get the reaction. I will calculate. 150 into 4 plus 90 into 7 plus half into 12 into 18 into 1 by 3 of 12 divided by 12. That reaction will come 138.5 kilonewton. See, everything I will calculate in front of you and enter. So, by chance, if any value is wrong, you check it and let me know in the comment section. Then minus half into 12 span into 18 minus 150 minus 90. This reaction will come 209.5 kilonewton. 209.5 kilonewton. I hope it is visible. Okay, now here also you need intensity here, intensity here. From this side you calculate 18 divided by this span 12 into distances, it will give the values. That will give you 18 by 12 is 1.5, 1.5 into 5 will give you 7.5 Kn per meter here. You have to calculate it. Here it will come either into 1.5 into 8 is 12 Kn per meter. This will come 12 Kn per meter. All calculated value, remember. Okay, now draw SFD BMD. Okay, calculation I explained so many times last time. Work out. Go up by 58. Sufficient. Okay. There more shear force is there. 58 is sufficient. Then here to here, come down by half into 3 into 3.6. 58 minus half into 3 into 3.6. It will come 52.6. That is very nearly equal, slightly lesser. See, 52.6. And intensity is 0 here, intensity increases, here 0 slope, here slope increases, it will come like this. See, this way. If I draw tangent here, 0 slope. Come down by 20. 32.6. It will be 32.6. Again from here to here, come down by this much load. How I already told you. Minus 3.6 plus 7.2 divided by 2 into 3. That will come 16.4 when you reach here. 16.4. Once again remember, slope here and slope here both should be same. Here, actually what will happen is, as you go this way, slope will, see here 32.6. Sorry, here you should see. This side and this side both should have slope same 3.6. Here slope is how much? It will be 7.2. So more slope there. See 32.6. I will put little higher side. 32.6. Okay, not zero slope here. Okay, now. Okay, that is sufficient. Here more slope. Come down by 60. Minus 60. Minus, see, suddenly you can see here now, shear force diagram crosses baseline at a known point. Minus 43.6 compared to 58, little more. Minus 43.6. Okay, reasonably okay. 43.6. From here to here, again come down by this much load. It will surely come 82 here. 82 here. Again, how? As you go this way, intensity increases, slope will increase. Okay, reasonably okay. Plus, minus. Now, locate the point where shear force is 0, not required. There is no point of 0 shear force here. Shear force diagram will cross the baseline at D. So later, BM at D is maximum. There is a finer concept is there that I will tell later. People who tell shear force just to left of D, just to right of D, those things all, they will tell it is not defined there. I will give a fitting reply for all those answers given which are not correct. Not now, later. Okay, now, this question, see. Go up by 209.5. You solve both separately, not this way. As you finish this one, you start this one. Then come to bending moment diagram. Here to here. Come down by this much load. So, 209.5 minus 18 plus 12 divided by 2 into 4. And remember here, intensity is maximum. Here, lesser. So, here, more slope, lesser slope. The value will be 149.5, somewhere here. 149.5. See, therefore, see, it will come this way. Here, more slope, lesser slope. Then, come down by 150. Oh, what a narrow escape. Suddenly comes to 0.5. See here, it will cross the baseline. I said the question. I know by chance it still comes positive and comes here. I would have changed the loading for today's class because I told SFD I want to cross baseline at a known point. Okay, just I one thing. This side a very small value, just 0.5. I check the answer from that side. 138.5. You don't bother. Minus half. 138.5 minus half into 8 into 12 minus 90 is, yes, 0.5 correct. It came plus because I took other way, no problem. You don't bother about those things. From here to here, again come down by this much load. So, already minus 0.5 minus 12 plus 7.5 divided by 2 into 3. That all you are right. Minus 29.5. 149, not bigger here, see, quite small. 29.5. I'll write somewhere here later. Okay. 29.5 here. And as you go this way, intensity becomes lesser. So slope will become lesser. So it will become this way. Not zero slope. Little slope is there here. Okay, I'll do one thing now. I will show little slope. Little slope is there here. Not correct now? Okay, okay. Okay, now okay. Somewhat out of scale. 29.75. Come down by 90, minus 90. 119.75. Available space I will use here, sufficient. This is 209. Okay. Out of scale, 119.75. Again from here to here, go down by this much load. Minus half into 5 into 7.5. It will come correctly 138.5 here. This is 209. 138.5 here, a little out of scale. So don't make an issue of that one. 3.5. And again, as here, zero slope should be there. See, this way, zero slope. Diagram closes. See, this is 138.5. Okay, little more. Okay, such things you should not bother. Okay, now, lastly, BM. Start. BM at A, 0. BM at B, 0. BM at C. Plus 58 into 3 minus half into 3 into 3.6 into 1 by 3 of 3. 168.6. Where I should write? 168.6 I will write here. Okay, if required, I'll change data. 168.6. BM here. Look this side only. 58 into 6 minus half into 6 into 7.2 into 1 by 3 of 6 minus 20 into 3. 244.8. See, 244.8. 168 is 80. Again, up to here. I should reduce slightly here so that scale problem. 168.6 here, so that I can manage there. Here it is 244.8. 244.8, you got there. Now important, here shear force is 58, here shear force 82, this side higher slope, this side lesser slope, and from here to here, slope should keep on decreasing. Here also, slope should decrease this way, and at this point, zero slope is not there, because why? Shear force is there. This side and that side, different slope will be there. Lesser slope this side. So, then here to here, see, slope is very less here. But that side, little severe slope. Okay. Now, see, this slope is 16.4, that slope is 244.8 here. This slope is 52.6, this slope is little lesser, 32.6. Okay, now, plus. I have not written it today. Yes, one place I will write here, SFD, because somehow it is teacher's instinct. Someone should not comment, not written what is that one. And BMD, kilonewton meter, sagging positive. Here, BM here 0, BM here. Look this side. 138.5 into 5. 5 into 5 minus half into 5 into 7.5 into 1 by 3 of 5 equal to 661.25. 661.25 is I write here. 661.25. Here BM, look this side only. 138.5 into 8 minus half into 8 is the total into 12 is the total load for 8 meter into 1 by 3 of 8 minus 90 into 3. 710. 661, little more. Okay, sufficient. 710. Now, here shear force is 209, high slope. Here 138, lesser slope. And again, as from here till here, when you come here, shear force reduces, slope reduces, and or if you go this way, slope increases. Here to here, slope will reduce. Here to here, slope will increase. And here, this side slope is 149. That side is very small slope. And one more thing, slope is not 0 there. See, here, little more slope. Here, and whereas here, slope is very small, almost what? 0. So, it will go this way. See, but still, little slope is there. Very small slope. I cannot show it. That is a problem, see. Okay, slight slope is there here, plus. And here to here, slope is more here. How much? 138 here. Okay. Here, this side slope is 119 something. This side slope is 29. That should be more steeper. I will make it steeper now. Okay, see. Actually, 710, 695. Okay. That is more steeper. This is flat. I told here, this side more slope, this side lesser slope. Finding fault, people who find fault, they will find everywhere. They will tell, see, there's a dot here, ink mark is there. People, those who comment that way, I am helpless. Now, purpose of all this to give you thorough knowledge. So, whatever effort I am putting, how much I explained last time, going through that one, correctly solve these two questions. Next time, I will go for some more questions of UDL, UVL and point load, maybe 2 or 3 questions. 2 or 3 classes more to complete coverage. Then I will go for couples and then overhanging beams. One by one will come in correct order. Okay. See you in the next class, class number 90. Thank you.